Welcome back. In the previous lecture, I created a stream processing application using a file source. In this video, I'll explain the working of the same application and elaborate more on the sources and sinks. So, let's start. Here is the example we created. How is it going to work? Let me explain. The program starts with reading a stream. The stream input is a directory. We call it a file input source, but it is a directory source. So, the read stream will look into the input directory and read all the available files. The file must be a JSON file. If you have other types of file in the directory, you may get an exception. So, we should make sure that the input directory contains JSON data files and nothing else. The first micro batch will read all the available files in the directory and load the data in this raw DF. Make sense? The rest is straightforward. Spark will apply these transformations and finally create the flattened DF, right? Finally, this flattened DF will be written to the output directory. Spark will also record the progress information to the checkpoint location. The checkpoint location holds information about the input directory and the files which you successfully processed in the first micro batch. While the micro batch job is running, the background thread keeps monitoring the progress of the micro batch. Let's assume that all of this reading, processing and writing finishes in 15 seconds. We define the trigger time as 1 minute. So, the background thread will wait for another 45 seconds. After that, the background thread will look into the input directory and check if we have received any new files. If not, the thread will wait and watch for new files to arrive. As soon as new files are created, the background thread will trigger the next micro batch. The next batch will read the new files and load them to your raw DF. The rest of the processing is the same. Your micro batch will apply the transformations, write the output to the target directory, and commit the progress in the checkpoint directory. Once your micro batch is over, the background thread will again take over the control and start planning for the next batch. And this goes on in an infinite loop. The streaming file source is much more flexible and it allows you to configure the following interesting options. The max files per trigger allows you to limit the number of files per micro batch. Let me add it. I am limiting it to 1 file per trigger. This option can be useful in some cases to achieve even workload for your micro batches. The clean source and the source archive dir options are often used together. This option allows you to archive the processed file automatically. The clean source takes two values, archive and delete. If you are setting archive option and source archive dir, the Spark will move the processed file to a given archive location. The delete option will simply delete the processed files. You should also understand that moving or deleting will add some time to each micro batch. On the other hand, a lot of processed file in the directory will also negatively impact your micro batches. So, you must clean your input directory. If you are running longer batches, you can use the clean source option. However, if you are running shorter batches and clean source is not feasible in the micro batch, you can create a separate cleaning job that might run daily. But make sure you are cleaning your input directory. Great. So now you understand the example and how it is going to work. Let's run it. I included 3 sample data files. I also have a Parquet version of the same data. This example uses JSON files, but you can also try changing the example to work with the Parquet files. You can copy one file in the output directory and run your application. Then you can copy the second and third files to see if the second batch is picking the new files. However, I am copying all of them at once. My example is going to pick 1 file per micro batch because we configured the max files per trigger option, right? Let me run it. The program started. Let's go to the Spark UI and wait for 3 micro batches to finish. Okay, so you can see this additional job. This job is created for inferring the schema. And these 3 are your micro batches. You can see your query name here, right? The first micro batch start time is shown here. The second one is started at this time. The difference between first and the second micro batch is less than 1 minute. But we set the trigger duration to 1 minute, right? Then why is this started even before 1 minute? Well, let's look at the third batch. This one is exactly 1 minute from the second batch, right? But why is it less than 1 minute for the first and the second batch? This difference happens because Spark tries to align the trigger time to a round off time. So, the first 2 triggers are where Spark will round off the trigger time, and from third trigger onwards, you should see a consistent trigger time until your micro batches are overrunning or they are waiting for new inputs. Great. Let's come back and check your output directory. You can see the output files here. If you want, you can even look at the checkpoint directory. Check the sources directory. You will see one file for each micro batch. The file name is the micro batch ID. Look inside the file and it shows which file was processed in this micro batch. I am showing it here, but we are not supposed to touch the checkpoint directory and its structure. The checkpoint is super critical for fault tolerance. I'll cover more about the checkpoint in the next video. So, we are done with the current example. However, let me talk a little about the output mode. Data Stream Writer allows you to specify 3 output modes: append, update, and complete. You can think of the append mode as insert only output. So, you will be using this mode when you know that you are not going to update any previous output, and each batch will write new records only. The update mode is like the upsert operation. You will see only those records which are either new or old value is updated. So you should be using this mode when you want to implement an upsert like operation. Finally, the complete mode is like overwrite the complete result. So you always get the entire output. You should use this mode when you want to overwrite the previous results with the new results. That is what the output mode means at a high level. However, you might find a lot of confusion around the output modes. In some cases, certain modes are not supported and Spark will throw an analysis exception. Let me show you some examples to make more sense of these modes. Here is the first example. In this example, we are counting words and I am using a complete output mode. Let me run this example and show you what it means to use the complete mode. I am sending the first input, hello Spark streaming. What do you expect as output? We have 3 words and each of those is appearing only once, right? So I can expect an output like this. Now let me send another input. This time I am sending hello Spark programming. What do you expect in the output? The word hello and Spark are now appearing again. So the count for these 2 words should update as 2. However, the count for the word streaming is not changed and it remains 1. We got a new word programming, so it should also show up in the result, right? So what do you expect in the output? I can see 2 possibilities for output. The first one shows the complete result. It shows the updated values for the word Spark and hello. It also shows the count for the word streaming, which is not changed. And you can also see the new word, programming. Whereas the second type of output is showing only the updated and the new values. It doesn't show the word count for the word streaming. Both of these outputs make sense. The first one is called complete mode output. The second one is called update mode output. So, what do you expect from my example? I am using the complete mode. So I am going to get the complete output. Here it is. You can change the output mode to update and try the same 2 inputs you will get the second type of output. Let me show you. It worked as expected, right? So these modes allow you to decide the type of the output that you want to see. You should be using the complete mode when you want to see and override the full result. You will be using update mode when you want to see updated and new values only. Now, what is the append mode? The append mode is to implement the insert only scenario. But the word count example doesn't make any meaningful sense to insert only values. Let's try to understand it. If I try the append mode, then I should expect an output like this for the first microbatch. All three words are new, and so they should show up in the output. Now if you send the second input, then you can expect the output like this. Why? Because programming is the only new word. Hello, Spark and streaming were already there in the previous result, so they should not appear. However, this kind of output is not at all meaningful. It doesn't make any sense for this example. Hence, the append mode is not allowed here. Spark APIs are smart enough to detect such problems, and they throw you an exception. Let me try. I'm changing it to append mode. Let me run it. What do you see? Analysis exception. Append output mode not supported when there are streaming aggregations. Why? Because aggregations such as count or sum might get updated in the future batches. Spark detects it and throws an error. The point is straight. Understand the meaning and purpose of your streaming code and use the output mode accordingly. At a high level, remember this mapping as your guiding principle. Append mode is for insert only. Update mode is for updates and inserts. And the complete mode is to override the previous results. All three output modes are not supported everywhere. Spark tries to catch your mistakes and throws analysis exception whenever possible. Make sense? Great. That's all for this video. See you again. Keep learning and keep growing.